There are about 400 billion stars in the Milky Way. Many of them have planets, big and small, rocky and watery. It seems that this multitude of planets simply must be teeming with aliens. But here's the question, where are they all? This question is called the Fermi Paradox, and it has been puzzling scientists for over 70 years. It all started in 1950, when Italian physicist Enrico Fermi was having lunch with colleagues in Los Alamos. They were joking harmlessly about aliens when suddenly Fermi seriously asked, "Where is everyone?" The universe is almost 14 billion years old, and our galaxy is about 13 billion. In that time, thousands or even hundreds of thousands of civilizations could have been born. Even if their rockets traveled at only 1% of the speed of light, which is about 1,800 miles per second. It would take them only a few million years to colonize the entire galaxy, which is nothing for the universe. But here's the paradox. We don't see any ships, signals, or even space debris like alien ship wrappers. So, what's the deal? Could it be that we are truly alone, the only lucky ones who managed to ignite the spark of intelligence in this cold ocean of cosmic space? Scientists propose a bunch of hypotheses. One of them has the grandiose name the Great Filter. It's the idea that life easily begins, but at a certain stage, for example, when transitioning from microbes to multicellular organisms or from intelligence to space travel, it cannot overcome some barrier and perishes. Perhaps we, humans, have already passed this filter, while other civilizations near Earth have not. Or maybe we haven't yet reached the Great Filter? But for now, let's forget about the gloomy cosmic hypotheses and assume that life among the stars does exist. What might it look like? The universe is not just Earth with its forests, oceans, and us, the YouTube video enthusiasts. Far out in space, there are planets with incredibly high gravity, scorching winds, icy deserts, and atmospheres where oxygen is a rare guest. If intelligent beings live somewhere beyond the solar system, they clearly do not resemble us. Their bodies, homes, technologies, appearance, all of this would depend on the natural conditions of the aliens' home world. Imagine a planet the size of Mars. The gravity there is about 38% of Earth's. If life evolved there, it would have to adapt to such conditions. Plants, for example, might become gigantic due to the low gravity, but fragile. On Earth, trees are held up by gravity, growing thick trunks, but on planets like Mars, they could stretch up to the sky 300 feet, like tall, thin blades of grass. Now imagine the local animals. They would be long-legged creatures with thin limbs, resembling spiders or herons. Due to the environmental conditions, it would be more convenient for them to leap dozens of feet rather than walk like we do. The animals' bones would be light, like those of birds, and their muscles not as powerful as ours. Why exert yourself if gravity isn't pressing down on you? And what would intelligent life be like? Aliens from such a planet could grow into real lanky acrobats. About 20 feet tall, with thin arms and legs like grasshoppers. Their cities would be built primarily upwards, not outwards. Towers made of lightweight materials, like carbon fibers, would rise for miles. With their gravity, building such gigantic structures would not be difficult. Instead of stairs, the green acrobats would create special platforms that could be easily jumped onto. Transportation? Forget about cars. With their lightweight skeleton and body, overall, they would fly on wings like giant dragonflies or move by jumping, like kangaroos on steroids. Their technology could take advantage of the weak gravity. For example, launching spacecraft would be a breeze. No need for powerful rockets, just a small push and you're already in orbit. Maybe such civilizations are looking down on us right now and thinking, what a bunch of small fry. How did they even survive to this day? But there are also downsides. Low gravity makes bodies much weaker. Earth's astronauts who spend months in orbit find that their bones become very brittle over time, and their muscles weaken. If interstellar inhabitants decided to visit Earth, they would simply be crushed upon arrival, like a piece of dough under a rolling pin. The evolution of such life would have taken a different path. Perhaps they would have developed a powerful exoskeleton, like insects, to maintain their form. Or they might have learned to live in a liquid environment, where the pressure compensates for the weakness of their bones. And also, their atmosphere could be denser than ours, which would allow these fragile life forms to be supported much more effectively. Imagine an intelligent octopus with wings, gliding through thick fog. There you have a resident of a low-gravity planet. Now let's move to a planet with opposite conditions. Let's take a super-Earth, a planet 2 to 3 times more massive than Earth, where gravity could be 2, 3, or even 5 times stronger than Earth's. There, every step is like a walk with a backpack full of bricks, and jumping is an unattainable dream. Plants in such worlds would be squat and sturdy. No towering trees, only dense bushes or moss creeping over rocks. They might grow underground, in cracks where gravity presses a little less, or cling to cliffs like vines. Animals would be low, wide, with powerful limbs and thick bones. Imagine something between an elephant and a turtle, but with a flat body to distribute weight. That would be a typical representative of the local fauna. Animals in such conditions would crawl rather than walk, or move on many short legs, like centipedes. Jumping there is like trying to take off with a heavy weight around your neck, so evolution told these animals. Guys, crawl, and don't get cocky. And intelligent beings? These guys would be real tough ones. About 3 feet tall, but with strong shoulders like sumo wrestlers, and thick legs like a rhinoceros. Their skeleton, literally, a steel frame, and muscles so strong that they could drive nails with them. Such giants could live in caves or low bunkers because building skyscrapers on such planets would be akin to suicide. Everything would collapse under its own weight. Transportation would also be fundamentally different from ours on Earth. Forget about wheels. Aliens in high gravity would ride on tracked platforms. Or they might invent something like magnetic cushions to glide over the surface. However, getting into space to the little ones would be more difficult. Rockets would have to be enormous, and fuel supplies would have to be immense to escape the gravitational trap. Maybe that's why we don't see them, the aliens. They just can't break away from their home planet? It's interesting that high gravity also affects the brain. Blood has a harder time reaching the head. So, aliens in such conditions simply wouldn't survive if their circulatory system hadn't evolved properly. Aliens might be born with multiple hearts to pump blood through their veins faster. And the atmosphere of their planet would likely be dense and heavy, like on Venus. Breathing there would be like trying to inhale air at the bottom of the ocean, so the lungs of the local inhabitants would be powerful, like bellows. Imagine an intelligent creature the size of a barrel, with the thick skin of a hippo and such loud breathing that it makes your ears pop. Would you like to meet one? While we wonder why aliens aren't knocking on our door, let's imagine how they might survive in their worlds, where the weather is not just a drizzle or a breeze, but a real challenge. On Earth, we are used to a mild climate. The sun pleasantly warms us with its rays, and the breeze brings coolness. Yes, sometimes there are storms, tornadoes, or earthquakes, but these are more the exception than the rule. However, on other planets, conditions can be such that an earthly hurricane would seem like a gentle breeze. What would life look like on planets with extreme weather? Let's start the conversation about weather with planets where eternal storms reign. Imagine a world like Jupiter, only smaller. The atmosphere there is a thick soup of methane and ammonia, and the winds blow at 300 miles per hour. On Earth, a hurricane with a speed of 70 miles per hour can already blow off roofs. What would an extraterrestrial hurricane do to a place like New York? It's frightening to imagine. Plants on such a planet would be true survivors. Low, tenacious, with roots that dig into the rock like anchors. Their leaves might roll into tubes to avoid tearing in the wind or be absent altogether. Why have them if photosynthesis occurs directly through the stems, like in corals? Animals would likely be streamlined with smooth bodies, like dolphins, to glide through hurricanes. Or, on the contrary, armored like tanks with thick scales to prevent being blown into the stratosphere. Now, let's return to intelligent beings. The local Homo sapiens would build cities underground. Their homes would be sturdy bunkers with domes capable of withstanding pressure, and access to the surface would only be through airlocks, like in a submarine. Aliens might harness the power of the wind, with giant turbines protruding from the ground providing energy. Entire metropolises hidden underground. Their clothing would be spacesuits with aerodynamic inserts to prevent being blown away by powerful air currents. Aliens might move around on flying platforms or cling to ropes like climbers. Their technology might be based on weather control. Imagine them taming storms to build a new residential complex. Now let's turn the rule 180 degrees. Let's move to planets where there's not a breeze or a cloud, just a scorching sun. Take a world like Mercury. During the day, temperatures reach up to 800 degrees Fahrenheit, and at night, -300. Plants there could survive by burrowing into the sand during the day and opening up at night to catch starlight. Their metabolism would be slow, like that of turtles, to conserve energy. Animals here would also be significantly different from those on Earth. They would be nocturnal hunters with heat-reflective skin, like mirrors, and huge eyes to see in the dark. During the day, they would hide in caves or under rocks, and at night, they would roam in search of water hidden in deep crevices. Intelligent inhabitants of such a world would be incredibly adept at adapting to harsh living conditions. Their cities would become underground labyrinths with cooling systems powered by solar energy. They might wear suits with radiators to avoid turning into barbecue, and build homes from heat-reflective materials like ceramics or metal. Their day would begin at sunset, and their technology would be focused on water extraction. Giant condensers would collect moisture from the atmosphere or ice from the polar caps. Or maybe they learned to live in the perpetual shadow of craters, where the sun doesn't reach as intensely, and built glass domes with artificial climates there. Could you handle such a lifestyle? Sleeping during the day and working at night? The weather isn't even the scariest thing. The atmosphere is what truly shapes life to its will. On Earth, we breathe a mixture of nitrogen and oxygen. But in space, there are as many mixture options as there are drops in the sea. Imagine a planet with a dense atmosphere like Venus, where the pressure is 90 times higher than on Earth, and the air is carbon dioxide with a hint of sulfuric acid. Plants there could feed not on light, but on chemical elements, processing sulfur and carbon like Earth's bacteria in volcanoes. They would resemble crystals or slime clinging to the scorching rocks. Animals? Sturdy, with shells like crabs to withstand pressure, and gills filtering the toxic air. They could swim in this dense atmosphere like fish in water, or crawl along the bottom, feeding on chemical deposits. If intelligent life managed to develop under such conditions, it would have to work hard to survive. The local aliens would build cities in the form of spheres, where the internal pressure balances the external. Their bodies would be dense, with small lungs, and they would breathe through membranes, extracting oxygen from carbon dioxide. Their technology would use heat, engines operating on thermal gradients, or batteries charged by acid rain. Or maybe they would become flying creatures, with wings helping them glide in the dense air, like birds in Earth's clouds. What if the atmosphere is thin, like on Mars? The pressure there is lower, 1% of Earth's, and the air is almost pure carbon dioxide. Plants would be sparse, with huge leaves to capture the faint light. Animals would be small with large lungs to get enough oxygen, and with fur to protect against the cold. Intelligent aliens would live under domes where they would maintain pressure and warmth comfortable for living. Their suits would be light but warm, and they would get energy from solar panels or nuclear reactors. Who knows, maybe on a nearby planet, such a civilization is already hiding from us. In some dome. So, we have explored these imaginary worlds and seen other amazing intelligent life. But let's return to Enrico Fermi's main question. If life in the universe can be so diverse, then where are all these aliens? Why is space silent, as if all the aliens suddenly left Chad? Besides the Great Filter hypothesis, there are other theories by scientists about why we haven't encountered any life in space. Let's examine a few hypotheses that researchers propose to solve this paradox. The first hypothesis. We are alone. It sounds sad, but perhaps Earth is a cosmic jackpot, and intelligent life is such a rarity that we won the universe's lottery. Life could have originated on millions of planets, but evolving to the level of space travelers is like solving a Rubik's Cube blindfolded, with your hands tied. Microbes. Sure, plants. Maybe animals, occasionally. But intelligence that builds rockets, we might have one chance in a trillion. If so, we are unique, like a snowflake in the desert, and the universe is our personal stadium without spectators. But then why are we so lucky? Maybe it's because of our star, atmosphere, or just a coincidence that gave us brains and curiosity. The second hypothesis states that aliens exist, but they are hiding. Maybe the aliens see us as noisy neighbors, and that's why they turned on the mode. Do not disturb. This theory is called the zoo hypothesis. Advanced civilizations have agreed to leave us alone, like rare creatures under glass. Their ships could be hovering above us, camouflaged, like in Star Wars. And the signals are encrypted in such a way that our radio telescopes perceive them as interference. I wonder how long aliens would try to keep themselves hidden in that case? The fourth hypothesis states that aliens are either too far away or have already gone extinct. Space is vast. Even light takes 100,000 years to cross the Milky Way. If a civilization sent a signal 1 million years ago from the other end of the galaxy, it hasn't reached us yet. Or the aliens developed rockets long before us and flew to the stars far, far away from us. Maybe. We missed the party, and all the guests left while we were tinkering with the wheel and the steam engine. Perhaps the aliens have gone into black holes or other dimensions where time flows differently, and are now exploring parallel worlds. The last of the known hypotheses is that we're not searching well. Our telescopes only see a tiny piece of the sky, and the SETI project listens to a narrow range of frequencies. Aliens might be communicating with lasers, gravitational waves, or something we can't even imagine. Maybe their signals are passing us by, and we just don't know how to catch a greeting on a quantum level. Or they are already here, but in the form of microscopic probes that we mistake for dust. What do you think? Should we send even more signals into space, or is it better to stay quiet? That's the mystery of the Fermi Paradox. No matter how hard people try, they haven't been able to find aliens yet. No traces, no voices, not even space debris. But what if they do exist? Write in the comments what you think. If you enjoyed this space journey, give it a like and subscribe. There's even more ahead of us. Mysteries of the universe.